Unit 1, Lesson 5, Multiplying and Dividing by a Monomial. So a monomial is a polynomial with just one term, and we're going to learn how to multiply by a monomial. So all you do is you multiply the two numerical coefficients first, so you multiply the two number parts together first, and then you multiply the two variable coefficients, so the two variables together. And usually you're going to have to include your exponent laws when you're multiplying variables together. Okay, so let's go ahead and do that. So multiply together 3x times 7x. Okay, so I'm going to multiply the numerical coefficient first. So take the two numbers and multiply them together. So 7 times 3 is 21. Step 2 is multiply the variable coefficients together and use your exponent laws. Okay, so I'm going to multiply the two variables together. So x times x. And remember, these guys have a little exponent 1 on them, right? When it's an exponent 1, you don't have to write it formally. So sometimes it's helpful, if it helps you, write in a little 1, okay, if it's not written. So we have to multiply x to the power of 1 times x to the power of 1. So remember, when you're multiplying powers with the same base, you keep the base and add the exponents. So x to the power of 1 times x to the power of 1 is x. Keep the base, and then we add the exponents. So 1 plus 1 is 2. So 3x times 7x is 21x squared. Okay, example 2. Negative 3x to the power of 4 times 6x squared y. And remember that y has a little 1 with it. Okay, so first multiply the numerical coefficients together. So multiply those two numbers together. So the negative 3 times the 6. So we get negative 18. And now multiply the variable coefficients together. So we can only use exponent laws when the variables have the same base, remember. So we can multiply x to the power of 4 times x to the power of 2. So how do we do that? We use our product rule. We keep our base and we add our exponents. So 4 plus 2 is 6. So the y doesn't have anything to multiply it with, so we just kind of keep the y there. Okay, think of it as it's y times 1, which is just y. So there's your final answer. Okay, let's try these examples. So these examples include the distributive property. Okay, so remember, when we have a monomial out in front of the brackets, we need to distribute it by every term inside of the brackets. That's what we learned for distributive property. Okay, so let's start with the 3x times the 3x. Well, first we multiply the two numerical coefficients together. So 3 times 3 is 9. And these are both x to the power of 1. So now I'm going to multiply x to the power of 1 times x to the power of 1 using my exponent laws. Keep the base, add the exponents. Okay, now let's multiply 3x by the second term. So 3x times 6. So multiply the two numbers together first. So 3 times 6 is 18. And x times just a 1, or I think there's not another term to multiply it by, so we just carry it down. We just have x. Let's look at number 2. So again, I'm going to do distributive property. So 2x squared times x, remember that's a exponent 1, and technically there's a numerical coefficient of 1 in front of that as well. Again, when there's not a numerical coefficient there, it's assumed that it's 1. So 2x squared times 1x to the power of 1. Multiply the numbers together first, so 2 times 1 is 2. Then multiply x squared times x to the power of 1. So keep the base, add the exponents. Okay, let's go ahead and multiply by the second term. So 2 times 4 is 8. And x squared times y, they don't have the same base, so we can't use our exponent laws on them. Therefore, we cannot multiply them together. So x squared times y is just x squared y. We can't combine them. Remember, these guys all have little exponent 1s. If that helps, you can write it in. Okay, negative 5x times 3xy. So numbers first. So negative 5 times 3 is negative 15. Now let's use our exponent laws when they have the same base. So x to the power of 1 we can multiply by the x to the power of 1. So we keep our base, add the exponents together, so we get 2. And then we just carry down our y because there's nothing to multiply it with. Okay, let's go ahead and do negative 5x times negative 11y. So multiply the numbers first. So negative 5 times negative 11 is positive 55. And there's nothing we can do with the variables because they're not the same base. So x times y is just xy. We can't combine them. Okay, now one more thing I want to bring to your attention is you should always make sure that your answer or your polynomial is simplified. Okay, what does that mean? Well, make sure that all like terms are combined. Okay, over here we were as simple as possible. It was simplified because these two terms are not like terms, so we can't combine them, right? Because one has a power of 2 and one has a power of 1. Over here though, there's some like terms actually that we can combine to simplify this further, right? This is a like term with this. Okay, so these are like terms. So we write down the ones we can't do anything with, and then let's combine these. So 8x squared y minus 15x squared y is minus 7x squared y, right? You just add together the two numbers, so 8 plus negative 15, and then you just keep the variables, plus 55xy. Now that is simplified, one more step further, because all like terms are combined. So now we are finished, because there's no like terms left in that polynomial. Okay, dividing by a monomial is the same. Okay, you're still going to use your exponent laws, so in this case it's going to be your quotient rule, right? We learned when you're dividing powers of the same base, you keep the base and subtract the exponents. And then all you do is you divide each term in the numerator by the term in the denominator. So, example 1, 12x squared y to the power of 5 divided by, okay, that big line means division, negative 2xy cubed. Divide the numerical coefficients first. So 12 divided by negative 2 is negative 6. And now use the quotient rule to divide each of the variables with the same base. So x squared divided by x to the power of 1. Okay, keep the base and subtract the exponents. So 2 subtract 1 is 1. And now let's divide y to the power of 5 by y to the power of 3, because they have the same base. So keep the base and subtract the exponents. So 5 minus 3 is 2. Okay, and you don't need to write the little 1, right? It's not wrong if you do, but you don't need to have it there. So this is your final answer. Okay, when you have a question like this, when the numerator is a polynomial, so there's tons of terms in the numerator. Okay, over here there's only the one term. Okay, so I'm just going to take each term in the numerator and divide it by 2x. So I'm going to take 8x squared and divide by 2x. Then I'm going to take 18x and divide by 2x. And then I'm going to take negative 6x cubed and divide it by 2x. Okay, so let's do the first term. 8x squared divided by 2x. So divide the numerical coefficients. So 8 divided by 2 is 4. Then divide the variables with the like bases using your exponent rule. Okay, so keep the base, subtract the exponents. Okay, now positive 18x divided by 2x. So we have 18 divided by 2, which is 9. And x to the power of 1 divided by x to the power of 1. Keep the base, subtract the exponents. We get x to the power of 0. Okay, we'll deal with that in a second. And the last one, negative 6x cubed divided by 2x. So negative 6 divided by 2 is negative 3. And x cubed divided by x to the power of 1 is keep the base, subtract the exponents. Okay, now let's just simplify this. So anything to the power of 0 is 1. Okay, if you try typing that into your calculator, do 1,000 to the power of 0 or 200 to the power of 0. The answer is always 1. So this actually becomes 4x times 9 times 1, okay, which is just 9. Okay, so I just had to simplify that middle term because x to the power of 0 is 1. Now, we scan from left to right. Are there any like terms in this polynomial? No, there are not, because they all have different variables and exponents. Okay? Now, the only last thing that you can do to make this an even more perfect answer is we usually like to order the terms from highest exponent to lowest exponent. So I'm just going to rearrange the order of the terms. I'm going to put the negative 3x squared first, because the x squared, that's the highest exponent. Then I'm going to put the 4x, because that's the next highest exponent. And I'm going to stick the 9 at the end, because it doesn't even have a variable and exponent. Okay, so it's always better to write your terms in order from highest exponent to lowest exponent. Okay, so in this lesson, to summarize, we learned how to multiply and divide by a monomial. So when you're multiplying by a monomial, you just multiply the number parts first, the numerical coefficients, multiply them together first. Then multiply the variable coefficients first, second, or the numerical parts second. Okay, and when you do that, remember to follow the rules of the product rule. So you add the exponents. And finally, remember that you can only use the product rule when the bases of the powers are the same. Okay, dividing by a monomial is the same. You just take every term in the numerator and divide it individually, one at a time, by the monomial in the denominator. Okay, and here you're going to divide the numerical coefficients first, then divide the variable coefficients that have the same base using your quotient rule. So you subtract the exponents.